Your org is afraid of going next-gen with your web apps. But what if there was a way for you to manage your risk? In this video, I'll explain to you first what a next-generation web application is. Secondly, I'll show you a technique for adopting it incrementally with ReScript. Thirdly, I'll show you an escape hatch so that you can minimize your risk. And lastly, I'll compare the pros and cons. To talk about what a next-gen web app is, we have to first talk about what next-gen web development is. And it is a vision for the future where the web is more reliable, more secure, and it's free from the preventable errors that plague it today. It's a movement away from languages that don't bring strong type systems, and an embrace of languages that do, and in the process eliminating an entire class of bugs. It is in part a reaction against JavaScript and its many, many problems, and it is also a rejection of TypeScript, which has attempted to bring more type safety to JavaScript, but in my opinion has failed. And if you want to know more about exactly what next-gen web development is, I've written a document that defines clearly what its vision is, what the current problem is, what the core principles are, and what its commitment to the future is. So if you'd like to read that document and get a fuller understanding of what next-gen web development is, and therefore what a next-gen web app looks like, then I'll make sure to put the link in the description of the video. All right, let's start by getting into this project and describe what we're doing here. So we have a React app created with create React app npx command, and it has, for those of you familiar, basically get to see the default application that comes with that is this React logo and this boilerplate code. What we're trying to do is embed a form in, which you're looking at right now, without having to write a lick of JavaScript or React. We're looking to basically pick a better language that outputs React as its compiler output. So we're looking for a language that so we've picked a language called ReScript that has React bindings. And so that way we can have React as basically the compiler output. So that's the goal, because we want to use a language with a stronger type system than TypeScript or can provide. So how do we bring that to our code base? Let's take a look. So going through the installation steps, there's a couple pathways. Either it's in our case, we're not following the new project pathway. We're trying to integrate into an existing JS project. So I ran this command right here, and then I went over to the React tab, and integrated an additional dependency for the ReScript React library, and integrated that. And that's basically all you need to get set up. It will guide you through, basically it'll detect that you're in an existing application, and it will go through the process of updating your scripts and so on. So let's take a look at those. So taking a look at our package.json, it detected that we are an existing project and added these res scoped commands for building the ReScript application. I also went and downloaded added the concurrently dependency to this code so that I could run both I could watch the ReScript file and make sure that it was compiling on save to the res.mjs file, which we'll get to, and also have the React server running at the same time. So that's a convenience. The other thing that you get during the installation process is this rescript.json file, and you have to be sure it has this BS dependencies section. These are dependencies for ReScript, and just be sure to specify ReScript core and ReScript React. You can specify the module type, so in our case ES module, and the where to find your ReScript files. And when we're talking about the output, where we can specify in this JSX section what the output will be. It can either be classic, which is like your React.create element, or it can be automatic, which for ReScript means they're going to use the JSX runtime library. So, last thing that we modified is this index.html file to bring in Tailwind as a dependency so that we could just make it look nice, easier. And so let's take a look at the registration form. What should we say about this? Well, maybe I can just sort of go with first impressions. I think the code is approachable. It looks a lot to me like JavaScript. It feels like JavaScript. Obviously, it has some type safety there, and it has types that JavaScript does not have. For example, this validate email function is returning an option of a string. So there's no such thing as the option type in JavaScript. All right, so let's continue on. These other validate functions are very similar. It has some really neat belt utilities, which basically belt is a pure functional library for operating on data structures. So if you're accessing the form email, obviously that is an optional type. Either there's nothing in the form or there's something. So if you want to access that safely, then you've got to use the belt utility library to operate on that option type. In this case, we're just accessing and we're saying like get it or supply a default, which is an empty string. Maybe I can describe the setup a little bit. We're not actually submitting the form. We're just using a set timeout to simulate what some asynchronicity there. And we can talk a little bit about types, I guess. When we submit it or when we mock submit it, we return either an OK response with a string or an error response with the string. So this would be the submission status: idle, submitting, success, or error. So we just saw the success and error type there. So what else is interesting? So we have we're parsing the inputs from the DOM elements in the case of the age, where it's an option of an integer, meaning that there could be an integer, there could not be an integer in the field. We're using the belt utility to basically parse the string value and convert it to an integer. So I guess moving on to the JSX-like syntax, we've got some classes. These are Tailwind classes just for styling. And here it's worthy to note that we have exhaustive type checking. So I guess it's interesting to note here that we have exhaustive type checking here. The compiler is forcing us to code for every scenario, whether we are in an invalid form state or in a valid form state. Same for these other input elements as well. And this is just operating on basically the React the React state, or in this case the bindings in ReScript for the React state. And then the last thing we have here is exhaustive checking on the submission status, where we're getting the response back and we're printing the error or success message. And in the case of the other types, we're not returning anything at all. So the last thing we're doing is exhaustive checking on the submission status, where we're coding for the success and error message that we get back from the response. And in all other cases, which is what that underscore means, we're not printing any error. So this is essentially the registration successful, and in the case of we fill out this form without example.com, it will come back with invalid email domain. So let's just, I guess, interact with it, see how it works. You saw a little bit of that. If I put in as soon as I put in a valid email regex, that particular element gets validated. You can't have you can't not have a password. You have to supply a password, and it's telling us that we need at least 8 characters. So as soon as we satisfy that, the form message goes away. And for the age, it has to be between 18 and 120. So as soon as we hit 18, it's in a valid. The whole form's in a valid state, and we can submit it. The API comes back with saying that we have to use example.com, so we'll put that back in there. We'll submit it again. Yay, we have successful registration. Great. So let's take a look at the registration form output. So here is the output in JSX, and it's worth saying that the React ReScript ensures that the JavaScript that's output is optimized for performance. So so here we have it in. So here we have the output in JavaScript and JSX runtime, that is. And yeah, it's interesting to knowing that you are coding in ReScript, and for example, all cases are being covered in React in exhaustive. The exhaustiveness checking is part of the language, so it's interesting to see how that translates into actual JavaScript, right? So we've got switch statements on age, email, password, and so on, and like the status of the form, like pristine, submitting, okay, and success, and so on. So it's very interesting to see the output. Now, the way that this is imported into the app.js is simply just by importing the registration form res.mjs file, and then just adding the component here. So you do have to specify .make, which is awkward, as it kind of violates the Pascal case constraints, but it's a compromise. But I've looked into how you could export it differently. Haven't been able to quite figure that out yet. That's okay. So now we should talk about, let's say that you've tried this out. You decide that, you know what, this isn't for me. We want to go back to just developing in React. Well, it's as simple as deleting all your .res files. You can keep these ReScript files. They're generated. These res.mjs files, they're generated, and you can keep them. You're going to have to keep the ReScript libraries as part of the dependencies, but you can go back to just developing in React. Now, would a developer? So, I mean, pros are that you have all of the features of a strongly typed language. And again, I encourage you to go back to that link if you want to see like a complete list of what I define as a next-gen web development language and what it means to be strongly typed. So I would go take a look at that. But so this, in my opinion, you get all the benefits of having a strongly typed next-gen web development language. And all of the security that brings to your development, like it compiles, it works. There's safe array access. There's no null pointer issues. There's no structural typing causing semantic loopholes. All of the typing is nominal, meaning that you can't accidentally plug one shape into another, one object into another object and have problems at runtime with implicit conversion and so on. All of these things are solved using ReScript. Now, the problem with the ejection option, the con, I would say, is that your developers are kind of left maintaining this JSX, highly optimized code, but it's JSX code. So that's not ideal. But I think overall, if you're looking to sort of experiment with if you're looking for a next-gen web dev technique that allows you to experiment with what it's like to develop in a next-gen web development language, and to see the benefits and to measure the results in
improved code quality, less less bugs in production, less distraction from feature work by going back and having developers go back and fix bugs, more code maintainability, then I would say having to, exhaustiveness checking, making sure every scenario is coded for, then I would say this is a strong candidate. Um, and it's worth looking into in your organization. If you want to see me delve deeper into next gen web development practices and interesting techniques like this one, like, subscribe, and follow me on the journey. Bye now.